Hi, hi students. I am R. Mohan Raj, Assistant Professor, Department of Electronics and Communication Engineering in K.S.Rangasamy College of Technology. Today we are going to see about small scale networks in mobile communication systems, mobile communication and networking systems. First introduction. So, what is there is wireless communication channels are not constant and vary continuously with the time and position. Small scale networks focus on analyzing rapid fluctuations of the received signal strength. So, this is a small scale networks. It can analyzing the various fluctuations from the different transmitter. These fluctuations occurs over very short distances, a few wavelength and short time intervals. So it can be measured by using the small scale networks. The main reason for these variations are multipath propagation, movement of users from one place to another place, and the surrounding objects. So the surrounding objects causes the main obstacles for transmitting signals, and it can delay in reaching the receiver. So this is a multipath schematic diagram for multipath propagation. So the sender can send the signals and the receiver can receiving the signals. So it can travel through many obstacles. So it can travel through many obstacles. So by reflecting from the objects, and there are three possibilities: the reflecting, diffraction, and scattering. So in these there are these steps are known as the multipath propagation. So it can crosses various obstacles, and through the various obstacles it can reaching the receiver. So this is known as the multipath propagation of signals. Next one definition, that is small scale network that is ideal with the study of short term variations in the received signal strength and quality. These variations are observed when the receiver moves over very small distances, typically in order of few wavelength. So based on the wavelength, so the wavelength can be calculated by means of the velocity and the size of dimensions of the object and frequency. So by measuring the ratio of the velocity and frequency, the wavelength of the object can be calculated. So signal fluctuations also occur over short time durations, especially in mobile environment. The variations are mainly caused by multipath fading and Doppler effects due to relative motions between transmitter and the receiver. Small scale network analysis helps in understanding fading characteristics and improving system performance. Next, the main causes of small scale variations. Multipath propagation occurs when the transmitter signal reaches the receiver through multiple paths due to reflection, diffraction, and scattering. Each multipath components arrives with a different delay and different phase and amplitude, causes rapid signal fluctuations. So next, relative motions between transmitter and receiver introduces Doppler shift, leading to frequency changes in the received signal, and movement of nearby objects such as vehicles, people, and building also alters the propagation path. So these factors together result in fast fading and rapid changes in the received signal strength. So these are all the main causes of small scale variations. It is mainly due to the Doppler effect. And next one, this diagram, that is ray diagram showing multiple signal path. So the transmitter can send the signal and it can reach the receiver, that is line of sight distance, that is equal to 1. So the what is my line of sight distance means there is no obstacles in between the transmitter and receiver. The propagation path can be straightly reach the receiver without any obstacles or without causing any scattering, diffraction or reflection. And another one is there is reflected path distance. So we can measure the reflected path distance by means of x plus x dash. So what is by x dash means that is it can be reflected ray or diffracted ray. So there is a measure of reflected path distance, and ground, that is distance between the ground, that is horizontal distance, equal to d. So this is by means of a ray diagram of multiple signal paths that can transmitted to the receiver, and the height can be calculated as between the ground and transmitter is ht. So this is a reflected image in the receiver side, so it can be calculated for multiple signal paths. And multipath propagation, in multipath propagation occurs when a transmitter signal reaches the receiver through multiple propagation paths. These paths are created due to reflection. So reflection usually occurs from the building and the ground, and diffraction, so diffraction, that is around obstacles, and scattering from small objects. So each multipath signal travels a different distance, resulting in different time delays at the receiver. The signals also differ in phase and amplitude, which may cause constructive or destructive interference. Multipath propagation is the primary cause of small scale fading in wireless communication system. And this is a illustration shows that LOS and NLOS, that is a line of sight and non-line of sight path converging at the receiver. So there is in the red line, so there is a signal from the transmitter and it can reaching the receiver without any reflection, so that is known as the non-line of sight, and with obstruction, so it can causes by the any obstruction, so that is known as the non-line of sight. Without causing any obstruction is known as non-line of sight. So that it can be causes by reflected waves and reflected from the buildings, etc. And next one, there is fading. So fading refers to the rapid variations in amplitude, phase or frequency of the received signal over time and space. It occurs mainly due to multipath propagation, where multiple signal components combine at the receiver. Depending on the relationship between signal bandwidth and channel bandwidth, the fading can be classified as flat fading. So flat fading means that is entire signal bandwidth is affected uniformly, and frequency selective fading, so that is different frequency components experience different fading levels. Fading causes signal distortion leading to higher bit error rates. And next one is there is Doppler effect. So the Doppler effects refers to change in frequency of the received signal caused by relative motion between the transmitter and the receiver. When the receiver moves towards the transmitter, the received frequency increases. When moving away, it decreases. So this is the main effect of the Doppler effect. And Doppler shift introduces time variation in wireless channel, leading to fast fading. So on the Doppler effect is given by the formula Fd, that is equal to V by lambda, where V is velocity of the mobile user and lambda is the wavelength of the signal. Doppler effect is significant in high-speed mobile communication systems such as vehicle and railway communications. And the main applications of this small scale networks is, that is cellular mobile communication system use small scale network analysis to combat fading and improve call quality and data reliability. In Wi-Fi and WLANs, small scale fading models help in optimizing antenna placement and transmission techniques. Vehicle communication systems V2V and V2I rely on Doppler effect and fading analysis due to high speed mobility. 5G and beyond wireless systems use small scale channel models for beamforming, massive MIMO and adaptive modulation. Indoor wireless networks such as offices and campuses use small scale analysis to ensure stable high data rate connectivity. So this is how the technologies are improved: 1G, 2G, 3G, 4G, and now 5G. Thank you.